Hello, I'm Paul. Welcome to MIG Monday. Today what I'd like to try and do is a little aluminum welding. And we're going to take this little wire welder here and weld aluminum with it. All we need really to do, in a kind of an overly simplistic method, is just change out the wire and change out the gas. Because welding aluminum, of course, we're going to have to use 100% argon, just as if you were TIG welding. So I also want to point out that just changing the wire and the gas, in some cases it might work, but typically aluminum is a little more problematic than that. And we're just going to go ahead and try and do it the quick, easy way, see what kind of problems we come into, then see what we can do to address those problems, all right? So I've taken the liberty to already have loaded some wire. I haven't run it up through the gun yet. I've just got it through the drive rolls to kind of control the end of the wire. And so right now what I want to do is just run it up through the gun to get ready for welding. I've already removed the contact tip. Some of you already know that's what I typically do when I run wire up, just to avoid any kind of problems with the wire coming up and trying to get through the contact tip. So I'm going to turn the machine on, pull the trigger and feed the wire. And of course, remember what I've always said, when you're doing this, when that wire comes out, it's going to be electrically hot, so make sure you don't have it anywhere where it's going to make contact and give you an unexpected arc. All right, wires come through. So far, so good. I'm going to put the contact tip in. And put the gas nozzle on. All right, now we should be ready for welding. So let me get my safety gear the rest of the way on, my safety glasses and helmet and gloves, and we'll get some metal here and we'll make a weld, all right? Hang on. All right, let's make a weld. Well, maybe we won't make a weld. It's not even feeding any wire. Yeah, and this is why. I don't know if you can see that, but this is what they call a bird's nest. The wire has not fed through the liner. It's kind of buckled up and got all gnarled up right at the drive rolls. So that's a pretty common problem with welding aluminum. So now we need to address that. This is all wire that didn't get fed because something stopped it from going down through the gun. And probably, since the drive rolls are pushing it, let's kind of look and see what's a possible cause here. The drive rolls are pushing the wire. And since there's plenty of wire here, we know the drive rolls are doing their job of pushing the wire up. The problem, apparently, is somewhere within the gun. Now, the first thing that comes to my mind with this quick, easy type of a setup is that maybe there's too many curves in the gun, which increases the friction, which makes it harder to push the aluminum. Remember, aluminum's pretty soft, so if it's not sliding through easily, you're going to have it's going to kind of pile up. I sometimes use the analogy of it's kind of like pushing a wet noodle through a straw. If it's a nice straight straw and maybe kind of downhill, it's not as difficult as if the straw is one of those crazy straws the kids use. You know, it's just not going to happen. And if you look right here, this is where my gun comes out and it comes off the table, so it drops down. So that's a relatively significant bend. And then, of course, the whole gun is just a big U. So typically, the first thing to do to overcome a problem of feeding like this is to have the gun almost out as straight as possible. Sometimes you'll be farther away from the machine, but you keep the run of the gun as straight as possible, and you're going to have a better chance of success. Won't necessarily cure it, because there are some other things that should be done. All right, well, let me get this bird nest straightened up, and then we'll get back to trying to weld. Okay, now I've cleared that bird nest, and I've got the wire fed into the gun liner, but I haven't fed it up to the gun yet. Now, if you recall, I mentioned that the problem is probably in the gun because the drive rolls were doing their job and pushing the wire. But there's a further question here is what kind of wire they're pushing. And I don't necessarily mean the chemistry of the wire, although that can factor in, and we'll talk about that in a little bit. But to feed the wire, you have to have pressure on the wire from in the drive roll system. And because aluminum is soft, instead of being nice and round, if there's too much pressure on the drive roll, you can compress the wire. You know, obviously, it's not going to be this dramatic, but I think you get the point that it's going to have edges and it's not going to be round. And the inside of the liner is round, so there's going to be increased friction, and all that can contribute to the failure of to make a weld. So one of the things we're going to do right first off is try to reduce the pressure on the drive roll by backing off the tension adjustment, so I have less tension and can still feed wire, but maybe not so much tension that I'm misshaping the wire. Okay, so let's give that a shot. And to do that, on most machines, there's a little graduated gauge thing here, so you know where you were if you ever changed out rolls and things like that. You can go back to your setting easily. So since I don't have a setting for this yet because I've not done this before, I'm just going to back this off a couple of numbers here and see if I still have enough pressure to actually feed the wire, but not so much that I'm going to distort the wire. So give that a shot. I backed it off to some random setting, and we'll just see what we can do. If it doesn't feed, I'll crank down a little more tension. If I still have problems, I can perhaps take a little more tension off even and see if that helps. All right, so let me turn the machine on. Pull the old trigger and feed some wire. All right, it appears to be feeding pretty good. And there we have some wire. I don't feel any rough edges or anything, so maybe this will work and solve our problem. So let me put the contact tip back on. Let the gas cone back on. All right, and once again, we'll don the old safety gear again and try to make a weld. Here we go. Okay, I'm not getting any electrical conductivity, and we have another bird nest. All right. By the time we're done with this, you guys will be real well versed in how to clear a bird's nest. There still are some things I can do to try and solve this problem. Remember, one of the things that you have when you mount the spool is you don't want to have too much tension on the spool that it makes it more difficult to feed, you know, that the drive rolls have to pull against a heavy force, and yet you don't want it so light that the reel will free spin and have the wire come loose. I don't think we're in any danger of having it free spin at this stage, so what I'd like to do is just release more tension off of the drive rolls, off of the spool, so it spins more freely. I already don't have very much on here, and there's not much room for any less tension adjustment here with this particular type of setup. So I'm going to remove this piece and just use the spring and the nut, because that'll put just a little bit of tension on this. Yeah, that moves much easier, and maybe that will solve the problem. And now what I'll also do is take a little bit more pressure off of the drive rolls by even reducing tension on here even a little bit more. And now let's see where we're going. Let me take this off. Take this off. Because the last thing I want to do is have any kind of little hit on the bottom edge of the. If it hits on the bottom edge of the contact tip, it gives it just a little bit of a glitch. That might be enough to create another bird's nest. So I'm just going to leave that off until I feed the wire. All right, almost ready to try it again. All right. Like take 3. Here we go. Well, we've pretty much exhausted what we can do to feed this wire with this machine. That doesn't mean this machine won't feed aluminum. What I'd like to point out real quickly to you is that this machine is actually designed to be used for the spool gun. That's what this little amphenol connection is right here. The company offers a spool gun, and basically what a spool gun is, it's just a handheld device. The wire is right on this device, and the feeding, like we have to feed down this whole gun, you actually only have to feed the thing about 4 inches before it comes out and makes your weld. So it eliminates all the feeding problems that we've been having here. Now, not all of these small wire welders have a cool little feature like the ability to hook up to a spool gun, but a lot of the other manufacturers that make small wire welders like this do have what they call aluminum feeding kits. And what that includes is a special drive roll. What we have on here is just the typical mild steel drive roll, and as you probably know, it's just a U-shaped groove in a roll that the wire nests in, and then you have the tension roll pushed down on it, and that's how you feed the wire. An aluminum feeding drive roll that still has that same U, but it's more polished so that it doesn't mar the wire, and it's deeper to help minimize the deformation of the wire when you put tension on the drive roll. Also, typically those wire feed speed, or those aluminum feeding kits come with a Teflon liner. In other words, inside this liner, and on all guns when you're MIG welding for that matter, you see this little spring here? They have a similar spring like that inside here. That's the liner, and it's metal. And so you're going to get some resistance that you normally would expect with metal to metal. With the Teflon liner, because it's slippery and it allows it to slide easier, also helps minimize any kind of friction that would cause this type of bird nesting issue. And even with the wire feeding, or the aluminum feeding kit, remember what I said earlier about being able to keep the gun as straight as possible. That will also minimize your problems when you're working with aluminum. And then one last thing I want to bring up, and that is the type of aluminum wire that you're using. What I have here is, this is called 40-43. 40 refers to the tensile strength of it. The 43 is chemistry. And it's about as soft of, well, it is the softest welding wire, I guess, that you can get in this type of a format. And if it's soft, again, I think I used a little earlier, the wet noodle through a straw scenario. It's kind of hard to push something that's very soft. The other aluminum that's available for welding, for the home hobby guy especially, is 53-56 aluminum. That's got alloy in it that makes it, it's a little higher tensile strength, but that alloy also makes the wire a little stiffer. In other words, it gives it more column strength, which, the column strength there makes it easier to push and overcome any resistance that you might have in the liner of the gun. So that would also enhance the ability to have a trouble-free weld. So that would be my recommendation. Either if the machine is equipped to accept a spool gun, that's the best option. If it's not, then the second best option would be to go with the aluminum feeding kit. Or you could just continue to struggle as I have. Maybe changing to 53-56 would allow me to make a more successful weld than I've been able to do here. But those are just things to take into consideration when you're trying to weld aluminum. Thanks for watching. We'll see you next time. Well, if you learned something today or like what you saw, please feel free to subscribe and keep an eye out for new episodes every MIG Monday.